purpose of today's lesson is to understand how to graph a line under three different methods. You're going to take some of the information that we learned or strategies we learned on Friday and apply them to now graphing a line. But before getting into that, the do now says we want to convert the equation 2x plus 3y equals 12 into slope-intercept form. As you should hopefully remember from Friday, slope-intercept form is the form y equals mx plus b, where what we want to do is substitute a value in for m being the slope, and for b being the y-intercept. When written in that form, that is a very helpful and useful tool for us, as you'll see in a couple of minutes. So to convert this into y equals mx plus b form, you should hopefully remember from earlier lessons on literal equations that we can transform any equation into any form we would like. And what we're looking to do is isolate the y. So what am I going to do first? I want to subtract 2x so that I get 3y equals negative 2x plus 12. Now, some of you might be inclined to write 12 minus 2x, which is not incorrect, but we like to keep our equation in this form just so to avoid any confusion. Another step to isolating the y is to divide by 3. Please remember that every separate term of your equation gets divided by the 3. So I get y equals negative 2/3 x plus 4. Okay, so now we want to get into the three separate methods we're going to use to graph the equation of a line. Method 1, as you'll see written, is using the slope and y-intercept. And we're going to follow the following pretty straightforward steps. 1, if necessary, rewrite the equation in slope-intercept form, meaning y equals mx plus b. Step 2, identify the slope, which is m, and the y-intercept, which is b. Step 3, plot the y-intercept first. Very important that you recognize that the y-intercept is a coordinate. Slope is not a coordinate. It tells us the steepness or the movement from one point to another on the line. From that point, meaning the y-intercept, use the slope to go up right if it's a positive slope or up left if it's a negative slope. Draw the line and don't forget to include the arrows. We need arrows since it's a line. If you do not put arrows, you're then telling me it's a line segment, which is something different. A line segment has a beginning and an end. A line has no beginning or no end. So let's graph each linear equation. Y equals 4x minus 1. We can identify the slope, which is 4, and the y-intercept, which is negative 1. So I can first graph the point negative 1, which is on the y-axis, because that is my y-intercept. Now, as it says above, from that point, I want to use my slope for movement. My slope is 4. We always want to write our slope as a fraction. And since there's no denominator, it is a denominator of 1. If you might recall from Friday, we use the words rise over run to help us understand slope. So the 4 tells us how much we rise, 4 units from the y-intercept. So 1, 2, 3, 4. The run tells me how many I'm going right to left. Since the overall slope is positive, I'm going to the right. Okay? My orientation's a little off, so it should be the 0.13. On the flip side, I could have gone down 4, 1, 2, 3, 4, and if I did that, I would have to go to the left 1. I do this in this exercise just to show you that when you do that, you get the straight line that you are looking for. Okay? Since the slope is a positive 4, you can see my line is going up to the right in the proper direction. Now, in the second one, we have the added step of having to convert this into y equals form. This should be pretty straightforward now. You get negative 2y equals negative 4x plus 8. Dividing everything by negative 2, you'll get as your equation y equals 2x minus 4. So that's the equation I'm going to use to graph. So what's the first point I can graph? My y-intercept of negative 4 on the y-axis. My slope is 2, or 2 over 1. That tells me I can go up 2 to the right 1, or conversely down 2 to the left 1. Either one works, and I have my line. Okay? So that's method 1, graphing using the slope and y-intercept. Method 2, creating a table of values. What we're going to do here is we're going to take our equation and we're going to find coordinates that are on this line. Meaning we want to find corresponding x and y values. Now, theoretically, you can choose any x coordinate you want to do this, but we like to keep the numbers very simple. And we usually choose 3 different x values just in case we make a math mistake somewhere. And I like to keep the numbers easy, so I'm going to choose a negative number. Negative 1's the easiest. 0, that's a very simple number to work with, and then a positive 1. So these are the 3 x coordinates. What do I need to figure out? Their y coordinate that goes with them. How do I do that? I plug in 3 times those 3 separate x coordinates and just do the math. And you'll see that you get as your corresponding y values negative 2, 1, and 4. Okay? So what this is doing is it's telling us we're going to graph 3 coordinates. Negative 1, negative 2, 0, 1, and 1, 4. Another point I would just like to make is if you look at the pattern, as the y values are changing, they're all going up by 3. And the x values are going up by 1. 3 divided by 1, change in y over change in x, is my slope of 3. That is not a coincidence. Okay? So now, what do? I'm going to plot those 3 points. And you'll see one of the points you're plotting is the y-intercept. So I plot negative 1, negative 2, 0, 1, and 1, 4. And the reason for doing 3 separate points is you can see they all line up. If you made a math error in your table above, one of these points wouldn't be in a line, and you would then hopefully realize that and go back and figure out your mistake. Okay? Now, in example 2, I have the additional step of having to convert this into y equals or slope-intercept form. So over here, I'm going to do that conversion. I subtract 6x. 3y equals negative 6x minus 12. Divide everything by 3. So I get y equals negative 2x minus 4. Okay? Now I'm going to go back, create a table of values. And I know there's a lot of information in here, but that's why I'm using all these different colors. Hopefully no one's having a problem with that. I'm going to choose the same negative 1, 0, 1. You can, again, choose any numbers here. However, you always want to be careful to choose x values that are going to give you integer values for y, meaning no decimals or fractions. I plug in 3 times again. and I get my corresponding y values to be able to plot. Again, you'll notice x and y are changing. Y is changing by -2, x is changing by 1. That is my slope of -2. No coincidence. That's the way it works. That's how it's all intertwined. So now I'm going to plot those three coordinates, -1, -2, which is here, 0, -4, and 1, -6. They form a nice straight line, and I am done. Okay. Now we're going to go to method 3. Method 3, as you'll see, says to graph by using the x and y intercept. So let's make a couple of notes here off to the side. As you'll recall from Friday, the y-intercept always has an x coordinate is 0. So extending that logic, the x-intercept should have a y coordinate of 0. Now, how are we going to do this? Well, let's divide this up. I want to figure out my y-intercept and my x-intercept. Well, if the y-intercept means x is 0, then what you're doing is you're putting 0 in for x and solving for y. Well, what you're left with is 3y equals -12, or y equals -4. You just found the coordinate 0, -4. On the flip side, I'm now going to let the y be 0. And you don't even have to write all of this out. You can just cut right to 6x equals -12, and that x is -2. That means -2, 0 is the x-intercept. So now all I need to do is graph those 2 points, 0, -4, and I'll have to move this a little bit. Apologize for going up and down like this. So again, I'm going to graph the point 0, -4, which is here, and my orientation is a little screwy, so I'll try to do the best I can. And then -2, 0, which is on the x-axis. And then I could just connect those 2 points. Sorry they didn't go right through, but I don't want to reorient that at this time. Okay, now I'm going to do the same thing here. My y-intercept and x-intercept. So my y-intercept, the x part disappears. I'm just left with 4y equals 8, which means y is equal to 2. So I'm at the coordinate 0, 2. And this one, the y disappears. So I'm left with -2x equals 8. X equals -4, which is the coordinate -4, 0. And I'm just going to graph those 2 points, 0, 2, 1, 2, 3, 4, -4, 0, and I am done. Okay? So what you saw in today's lesson was 3 different methods to graph the equation of a line. Using the slope and y-intercept, creating a table of values, and using the x and y intercepts. When you think back on this, method 1 is clearly the easiest method, especially if your line is already in the form y equals mx plus b. Method 2 is a little bit more cumbersome because it still requires you to put the line into y equals mx plus b form and then do a computation a couple of different times. So 1 is definitely the easiest. 3 is probably the second easiest. And then 2 is the other method that can be used. We'd like to teach you all 3 methods so that you have some flexibility. The only point or final point I want to make, one of the problems with the last method is, and you'll notice from above, all of the numbers were factors or of each other or multiples of each other. If you had something like 5x plus 2y equals 12, then when you're trying to find the x and y intercept, you're not going to get integer values. And so that's one of the downsides to using the x and y intercept. So as long as you have multiple ways to do things, you can figure out which one is the best to use, and that'll be helpful to you. We eventually will get to showing you how to do this on the graphing calculator.